Okay, this is to do with differentiation, which is rate of change or gradients or instantaneous rate of change. So for a straight line graph like this, we know the gradient is 3. You would have done that in a previous school. And for any straight line, you can always find the gradient here. And for any equation of this type, it's always this value here. In positive 3 in this case. But we can write, this is new notation, this just basically means the rate of change of y compared to x, because actually the gradient here is how far y changes divided by how far x changes. So if we look at here, this is the circumference is 2 pi r. If I increased r, what's the gradient or the rate of change of c? Okay, well this is of the form that we've just had. It's mx plus c, or in this case mr plus a value, or kr plus b if you have it that way. And so here the gradient is 2 pi. And so that's how I would work out the gradient here. Now, that's okay for linear graphs, but if we have a quadratic, clearly the bigger gradients here get smaller and smaller as I go towards 0. At 0 it's 0 if we look at this as a x squared graph, and then we have negative gradient here getting bigger, negative. So how do I find the gradient there? Well, if we have formula y equals x to the power of n, 2 in this case, then the formula for dy by dx is nx n minus 1 to the power of n minus 1. So in this case, n is 2, and so dy by dx would be 2x, just 2x, because 2 minus 1 is obviously 1, and x to the power of 1, you are expected to be able to write x to the power of 1 as x. So how does this help me with finding the gradient? Well, at x equals 2, I use this gradient here. 2 times 2 is 4. At x equals 6, 2 times 6 is 12, which is what you would expect if you look here. The bigger the value of x, the steeper this is, and so the bigger the gradient is, which is what we're getting. So let's have a look at these graphs here. What about y equals 10? Well, 10 is just a horizontal line on the gradient, on the axes, so it has no gradient. And so for any value here, y equals k, then the gradient or the differential is 0, and that's whatever that value is there, as long as it doesn't have anything to do with x there. Here I can link the both together and just do them individually, so I can work this one out and this one out and just add them together. So this one is 10x, this one is 3, because x to the 1 is 1 minus 1 is 0, and x to the 0 is just 1, and so that becomes 10x plus 3. Here is x, this is x to the minus 3, and so that becomes minus 3x to the power of minus 4, because I take 1 away from minus 3, gives me minus 4, which gives me that, which is just, I can write like that. So you should be able to have a go at some of the first a couple of the first exercises in the chapter. Let's have a look at here. So if I want an area now, so as my area gets big, as my radius gets bigger, what's happening to my area? If I differentiate that, I get 2 pi r, which means that the area, the rate of change of area is dependent on the radius, which makes sense because the further out I go, for a similar increase of 1, the annulus is a lot bigger area, and so you would expect that. Okay, now you can find a tangent to a quadratic or a curve. A tangent has the same gradient at a point of intersection, at the single point of intersection. So here, because it has the same gradient, we can work out the gradient of this x squared graph. We know it's 2x. We know that when x equals 3, the gradient is 6. And so this equation, because it's a straight line, has a gradient 6. So it's of this form. So all I need to do now is work out b. Well, fortunately, we know it only touches at one point, and we know that point is x. And so when x is 3, y is 9. And so I can use this fact of x is 3, y is 9 to work out what b is. In this case is minus 9. And then that gives me the equation of this line, 6x minus 9. And that's a very typical question for an examination in GCSE higher tier. It even gets asked in P1, which is your first course in A level. Now, these points here where the gradient is 0 are known as turning points. So for a x squared graph, it's a local minimum because it's the minimum point of the turning point, and for a minus x squared graph, an n-shaped graph, it's a maximum. Now, the thing about for quadratics is that this is the point of symmetry. So because this is a parabola, when the gradient is 0, the line that goes through that point, the x equals line, is where it is symmetrical. So if we do an example, here's an equation of a quadratic. If I want to find a line of symmetry, okay, I differentiate to give that. That gives me x is 2.5, and so my line of symmetry would be x equals 2.5. If I wanted to find the coordinate, I'd put x equals 2.5 into here, and it would give me the actual coordinate of the turning point. Okay, next thing is optimization. If I have got a box of 20 a square piece of paper of 20 centimeters, and I cut out squares in the corner of distance x, fold these slips up, I get an open box. Okay, and I want to find the open box's maximum volume. Now to do that, I just have to work out the area of this square that's left over times the x distance here. Now the area of this square is 20 minus 2x squared, because it's a square, which is here, and then I've just expanded it to give me what the volume is. Now I want to find the maximum value this can take as x changes, and now I can do that by I know that the maximum value of this is going to be when dv by dx is equal to 0. Okay, so if I differentiate that, I get this, and I need to make that equal to 0. Now that's a quadratic. It has 0, 1 or 2 solutions. So in this case, to make x equal 0, it has 2 solutions. Now clearly x can't be 10, because that would mean I would be cutting it and there'd be nothing left, and so x has to equal 10 over 3. If x equals 10 over 3, I put that into the equation, it gives me a volume of 592.6 centimeters cubed. Okay, the only other thing you have to know is this, that in physics, s is denoted by the distance. Now the velocity or speed of something is the rate of change of distance divided over time. So it's ds by dt. So if you give an equation, s equals, I don't know, ut plus a half at squared, which is a equation of motion, which we all will do in M1, then to find the velocity, you differentiate it. And then to find the acceleration, you differentiate the velocity, because it's how quickly the rate of change of velocity is happening. Okay, so that basically covers all the questions in the book. I will send you the video, PowerPoint, and the questions from that chapter, and have a go at these questions here, which are the end questions in the book.